Hi guys, this is Dr. Callahan for week 9, Monday for Calculus AB. I hope you guys had a good weekend. Go ahead and pause the video and answer the following 3 questions for your warm-up. All right, you guys, let's go ahead and take a look at the first question. So then looking at this right here, you guys know that there is a relationship between the position function, which is f of x, and also the f prime of x, which is the first derivative, and that's going to give you the velocity from the position function. And you find the second derivative of the original position function, or I guess in this case it will be velocity, or the first derivative velocity, you will then get acceleration. So that's kind of like the relationship between first, second, and derivatives as you apply it towards a word problem. So then let's go ahead and take a look at this question here. It says the position on meters of a particle moving in the x-axis is given by this. So that right here is going to be the position function of the moving item. At all time, t is greater than 0, obviously, because when you're driving, for example, I mean, you can't really rewind backwards unless you're in a movie. You can't really go back to -5 seconds. You know, when you're driving, you're just moving forward, and the time is going forward, so its time is greater than 0. Find the acceleration, so a of t, and remember acceleration is going to be the derivative of the velocity, or in this case, it's double prime for x of t, where the velocity is 4 meters per second. So it's given to you that the velocity is 4 meters per second, and it's also given to you that x of t is equal to 2t cubed minus 2t plus 1. Well, if it's giving me velocity and I have the position function, well, maybe I should go ahead and find where velocity is. And the velocity is going to be the first derivative of x of t. So in that case, it is going to give you, oh, you know what? I'm sorry. Hold on a second. I'm completely writing down for the wrong equation. Hold on. Let me go back to this. Yeah, this is fine. Velocity equals, yeah, so we're good. 6t squared minus 2t. So that is going to be your velocity. And you also know that your velocity is going to equal to 4 because that's what's given. So looking at this part right here, let's go ahead and solve for t. So to do that, I'm going to go ahead and, oh, you know what? I did this wrong. Hold on a second. Let me get rid of this t. Just kidding. Because the derivative of negative 2t is just a negative 2. I'm going to add the 2 on both sides. So 6t squared equals 4 plus 2 is a 6. Divided by 6 on both sides, t squared equals a 1. So then my t equals the square root of 1. So t equals positive or negative 1. Well, you can't have negative 1. So t is just equal to positive 1 second. And so then what I'm going to do with this is it says find the acceleration. So I would have to get to acceleration when the velocity is 4 meters per second. Well, I know the time is at 1, but I don't have the acceleration. So what is your acceleration going to be? Well, if velocity equals 6t squared minus 2, then I know that my velocity prime or x double prime is going to give me my acceleration, which in this case is going to be the derivative of 6t squared, and that is going to give me a 12t. Now I know my t is 1, so a of 1 is equal to 12 times 1, which is 12 meters per second, and it's squared because with acceleration, it is always squared. All right, let's take a look at the next example. It says a billiard ball is hit and travels in a straight line. If x centimeters in the distance of the ball is from its initial position of t seconds, then x of t equals 5t squared minus 4t. So this right here is given me the x of t, if the ball is hitting a cushion that is 12 meters from the initial position, so again, this is 12 meters x of t, not, like the last one was a velocity, so it's just position function. At what velocity, so the question is asking you for velocity, does it hit the cushion? So once again, you know that x of t, x prime of t is going to give you velocity. And I don't think it asks you for anything about acceleration, so I don't need to actually go that far. So looking at this, I have x of t is equal to 5t squared minus 4t. And I can go ahead and set that equal to 12 because this 12 centimeters is from the initial position. So then I know that x prime of t is going to give me 10t minus 4. Now the question says, what velocity does it hit the cushion? So it's actually asking you in terms of time as well. So I'm going to take the x of t and I'm going to go ahead and factor it and solve for t. So then looking at this, I'm going to have 5t squared minus 4t, move the 12 over. So this was different than the last one because the last one you didn't have like an x or a t, so you can just add the number. In the last one, it was actually the -2. So remember, you just added the 2 on both sides because there's no t here. But with this one, you do have a t, so you would have to just factor it. So you cannot just simply solve it with a square. So set equal to 0. So then you can ask yourself, what times what gives me 5t squared? So I'm going to put 5t and t. And then what times what gives me a -12? And I'm just going to make a guess right here. So I'm going to do -6 and a 2. But when I crisscross and multiply them and add them, it has to be a -4t. So here I have 10t minus 6t. That's a +4. And I want a -4. So what that tells me is that these numbers are good, but I need to change the signs. So then rather than putting a negative on top, let's put a positive and a negative on the bottom. So -10t plus 6t does equal -4t? Yes, it does. So then what is my answer? My answer when I factor this, you just go horizontally across, is going to be 5t plus 6, t minus 2 equals 0. And when you solve for t equals -6 over 5, and t equals a +2. Well, like I said before, you cannot have a negative time. So let's cross that out. So the only one that's feasible is t equals 2 seconds. Okay, so then after I have that, and I also have the velocity, which is x prime of t, what I'm going to do is I'm going to go ahead and plug in my t for the velocity, which is 2 seconds, and I'm going to get 10 times 2 is 20, minus 4, which is 16. The unit is centimeters per second. And notice that it is per second, 1 second, not like second squared, or second to the first power, because you're dealing with a velocity. So I should really go back to this one more time and accentuate that when you're doing velocity, it is always like centimeters per second. Here, it's like centimeters per second squared, okay, for acceleration. All right, so let's go ahead and proceed forward with what we're doing today. This is the breakdown of today's stuff, so you can go ahead and take a look at that. I'm going to have you guys do a little bit of desk work with practices. It's going to be 10 questions. In addition to that, I have a calculus puzzle that's going to deal with Ln. So you're going to be doing derivatives of Ln and practice that for a little bit. I also have a video example on 8 questions with your guided notes. And I believe today you might actually have a new packet. I think it's for week 9. All right, so then with that said, let's go ahead and move forward. All right, so since you guys are at home, let's go ahead and get started with the calculus puzzles first, and we'll just jump right in. So your guided notes today looks like this. This is going to be your first page of your guided notes. It's going to be on week 9, Monday, so you want to turn over to that. Your second page looks like this right here. And this right here is going to be the question that you're going to be doing as a review. If you do need the video, I do have the video right here that you can watch as well. All right, so then with that said, let's go ahead and get started. Okay, so how can two lumberjack chop trees in perfect synchronization? So take a look over here on the right side. You have a bunch of derivative rules, and I also introduced guys to U, which is kind of the, chain derivative. So today we're going to talk about ln u. So derivative of ln u is going to be 1 over u times u prime. So that's where the chain happens. But we're going to be mixing that with the quotient rule, the trig functions, etc. So that can definitely make it a little bit more complicated. Product rule, quotient rule. Eventually, we're going to do derivative log u, e to the u, which is very similar to ln u. It's like the reverse of that. And then a to the u. And then, of course, we've already done these ones here. So if you just check this out and see what we have accomplished so far, we have done the power rule. Today, we're going to go over the ln. We haven't gone over logs yet, but we have seen e to the u, have not seen a to the u yet, but everything here we have gone through. But it's good to have that as a little reminder. All right, so if I have derivative of ln x, and remember, it has to be just x. It cannot be anything else. Then my derivative is going to be equal to 1 over x. However, if it's not an x, and it can be any other thing besides x, let's say, for example, it's u, and u could be like x squared, or it could be 2x, or it could be square root of x. Anything that is not just x, you will have to do 1 over u times u prime. And this right here is where the chain kind of happens. So with that said, let's go ahead and go on to an example. So for this one here, it is number 10 on your calculus puzzle. And so here it says y equals x times ln e. So it's kind of an interesting one. So you will have to do the product rule, which is fine. So x is going to be my f. That'll be my g. So f is equal to x, f prime equals 1. G is equal to ln e. And notice this is not x, okay? It's ln e. So then if I'm going to do a derivative of ln u, it has to be 1 over u times u prime. So then the derivative for this is going to be 1 over u. And remember, u is e because you're going to say, okay, let u equals e. Then u prime equals, what's the derivative of e? Well, the derivative of e is going to be e to the u times u prime. And what is the derivative of e? Well, it's e to the 1. Okay, so you're kind of doing like a derivative instead of a derivative, a chain within a chain. So this is going to be derivative of e prime, which is going to be e to the u. So we're going to have e to the 1 power times u prime. And what is the derivative of 1? It is 0. I, for some reason, think this is not correct. Give me 1 second. Well, when in doubt, you can always Google it. Let's see what it says. I'm like, well, actually, I would think like L and E would just cancel. It would just be 1. I think it is 0, actually. Yeah, it is. So I think we're on the right track. So this is good. Let's just go forward with it. Because I'm thinking like, back in algebra 2, ln of e does not become a 1. So if g equals 1, then g prime equals 0. And the same thing goes here because this is still 0. So let's just move on forward. I'm like, at first I'm thinking, it can't possibly be that. But then as I'm thinking about this, I'm like, well, there's no other way of doing this. So y prime equals f prime times g plus f times g prime. So the first part is f prime times g. That is going to be 1 times ln e, which is just ln e, plus f times g prime, f times g prime, x times 0 is just 0. So I'm thinking that y prime equals just ln e, and that is your answer. I see that there's an ln x, but I don't see the ln e. So I'm thinking like maybe we are doing it wrong. I'm like, but that, I'm not sure. Hold on a second. ln prime. Well, that would technically still just be 1. Is there an answer here that is 1? Oh, it is. It's right here. Ta-da! There you go. Yeah, that was cleverly hidden. So sorry about that. So that would be L. So number 10 is going to be L. All right, let's go on to the next one. All right, so looking at this one here, there's nothing you could do inside the parenthesis. You cannot condense a fraction into a one single fraction. So you know you're going to have to do the quotient rule somehow. And if you don't like having an x over x plus 1, what you can do is you can go ahead and say, let u be x over x plus 1. Then u prime, so you guessed it, you will have to do the quotient rule. So we're going to say f equals x, f prime equals 1, g equals x plus 1, g prime equals 1. So then your u prime is f prime times g minus f times g prime over x squared, or g squared. So then g squared is going to be x plus 1 squared, which is the same thing as x squared plus 2x plus 1. So let's go ahead and plug that in. F prime times g is just going to be x plus 1 minus f times g prime, x, so that part cancels, and you get a 1 actually, all the way over x plus 1 squared. I'm going to leave it in the square, or in the parentheses squared, so that way I can kind of go back and forth between that form and this form. Maybe we'll cancel something. I don't know. We'll have to see where this leads us. But at least I have my u prime. So then here, I'm going to have y equals ln u. And you know y prime is a derivative of ln u, which is 1 over u times u prime. Well, lucky for you, we already have all the components we needed. I mean, we have u prime, and we definitely have u. So let's just go ahead and plug that in. So y prime equals 1 over u. Well, if it's 1 over u, it's going to be a 1 over x divided by x plus 1, which is the same thing as 1 divided by x over x plus 1, which is the same thing as 1 times x plus 1 over x, which is just x plus 1 over x. And we're going to do that on the side so that way we don't like waste a bunch of times, with the actual problem. Oops. And then you have u prime, which is 1 over x plus 1 squared. And ta-da, this is exactly what we decided to keep it in parentheses because there is a light at the end of the tunnel and it does cancel out. So 1 over x times x plus 1 is your answer. So let's go back to the puzzle. And let's find it. Except I don't see it. Hold on a second. 1 over x plus x plus 1. Oh, it will be this one here. Because if you think about it, 1 over x times x plus 1, same thing as 1 over x squared plus x. So m. Yeah. And that one was 18. So number 18 is m. All right, last one to go over with you guys is this one here. Oh, no, stop. All right, so looking at this one right here, you have y equals, I don't like the square root, so I'm gonna do x to the 1/2 times ln x. So you would have to do a product rule in this case. So I'm gonna say f equals x to the 1/2, f prime equals 1/2 x to the negative 1/2, g equals ln x, g prime equals 1/x. So then looking at this right here, you have y prime is equal to f prime times g plus f times g prime. So then let's go ahead and plug that in. First part that we're going to have is f prime times g. So f prime times g. Oh, and one thing I should notate about the f prime is that I want to rewrite that. So I don't have a negative 1/2 because it's really kind of hard to simplify that. So f prime times g, I'm going to have a ln x over 2x to the 1/2 plus, and then I'm going to have the f prime times g, or f times g prime, so f times g prime. So I have an x to the 1/2 over x. And you want to go ahead and simplify that a little bit. So if I were to go ahead and bring this 1/2 down, I will then have a 1 over x, and this is a 2 over 2, minus a 1/2, which is a 1/2. Now that I have something that looks like this, I will need to go ahead and combine the two together, the two fractions together. Since I have a 2 here, I will have to multiply this one by a 2 as well. And 2 times a 1 is just a 2. So we're going to get rid of the 2 up here. Because again, it's all about matching the correct answers. So now let's add it. ln x plus 2 is ln x plus 2 over 2x to the 1/2. And that is your answer. All right, you guys. So what I would like you guys to do for the remaining part of the class is go ahead and complete this puzzle and see where you guys kind of fall into and answer the following. And then after that, I would like you guys to move on to this page right here and give this a try as a review, because remember, you cannot forget the items that you guys do for the AP exam in May. And if you need any assistance, there is a video right here with a capital H, which is important. All right, guys, I hope you guys have a wonderful Monday and take care.